Thank you, Paula. Thank you, everyone, for coming. My name is Martin, and I would like to share my experiences with basically what you see as the title of this talk. So the idea is, about 8 months ago, I didn't know, well, basically anything about blockchain, and I got started working on a project and another project related to it. I will tell you more details about it, and like my hope is that my learning experiences are recent enough that I can share some of that with you and impart it onto you. And the idea of this talk is I would like to talk very briefly about the stuff that we need to talk about and then spend most of the time looking at examples. I prepared 3 simple projects for you that I will show you. So let's jump into it. Just some context on me. So as I mentioned, I didn't really have any prior blockchain experience. Also, basically everything you will see here will be written in JavaScript and JavaScript ecosystem. So there was also something that I didn't know much about. But I did have some general IT knowledge, so I wasn't started from complete scratch. So but what I want to say by this is that really, even if you feel like you don't know much about this, it's not really that hard to learn. Like I will show you some suggestions. I think the most important thing, like with many other things, is just to start, to jump into it. So of course, if you want to do, well, basically anything, you need to know at least some basics about it. Like you need to know the terms that are on this slide. I will talk about them. There are many resources that you can use, like for example, CoinStory probably, and also I will suggest some other ones. Well, one of the most important lessons that I had to realize at the start is the title of this slide, like blockchain can hold arbitrary data. Coming to this as an outsider, I was thinking about crypto basically just, or blockchain just in relation to cryptocurrencies, specifically the use case like money. And from that perspective, you've seen in the previous slide how Bitcoin works roughly. Like you have some information about the transactions that go on. If I've simplified super much, you have data that says like this address sends this much money to this address. You can do something like that. But when you are thinking like you are making your own blockchain, there's nothing really stopping you. You can put basically anything you want in there, like as long as it makes sense. And one thing you can do is you can put code in there. You can design an abstract machine. This is what Ethereum came with. They made their EVM, their abstract machine, which is like obviously not a physical machine. This is part of the Ethereum protocol. And it's an abstract machine with an instruction set, which you can imagine. This is a bit of a stretch, but you can imagine it kind of like CPU's instruction set. But it's of course very different because it's a different thing. But like in some cases, in some ways, it's simpler. In others, it's more complicated. But I would say in more cases, it's simpler. And yeah, I should mention, like this is not the only virtual machine that exists. Like other chains can have their own, other than EVM, and there are blockchains other than Ethereum that support EVM. And so what are smart contracts? In the context of Ethereum, they are basically code in this for this abstract machine that you send to the blockchain. It then gets assigned an address. It like lives on the blockchain, you can imagine. Like you can send transactions to that address to trigger that code. And it also has some state. So you can have like variables in the code. You can store some data, all kinds of things. One consideration to think about is that computation on the blockchain costs gas. So the idea is that each instruction has some cost associated with it. And basically, you have to pay Ether or whatever the base currency of the chain you are running on is for the computation. So when you are triggering some computation, you can specify a gas limit. And if the computation exceeds this gas limit, then it gets reverted, nothing happens, and you still lose your money. So this is something you need to consider. However, there are test networks, of course, where you can try this with basically fake money. You can get the money for free and just do whatever. And it should behave like similarly as it does on the main network. Although, of course, like people will behave differently on a test network. You cannot test everything, but the technology itself you can simulate with a test network. And then what's a DApp? Because I mentioned that before. It's basically just a shortening of a decentralized application. It's kind of a buzzword in this context. For the purposes of this talk, we can think about it as any application that uses a smart contract as one of its components. So basically, you can have the smart contract living on the blockchain, in the blockchain world, and then you can have like classical applications talking to this contract to do whatever you want to do. And I mentioned the EVM has like some sort of instructions, an instruction set. You don't have to write code in this. There are high-level languages for this purpose. One of the most popular ones is Solidity. It's an object-oriented language. Actually, I can immediately show you an example. Don't worry about it too much. Like I will show you a different smart contract soon. This is just so you can see like roughly how it looks. Personally, it reminds me a lot of classes in like Java or C++. Like you have the contract. It can have some member variables. It can have some methods, although they are not called methods, but they behave similarly in some sense. And yeah, so that's basically all the prerequisites that we have to go through. And what I have planned for you is I prepared 3 projects. They are in a repo on GitHub that I will share with you. And basically, first there's a smart contract. Then there's a simple web application that talks to the smart contract. And then there's a script that gets some information from the smart contract. So let's go over this point by point. And yeah, first, so I want to introduce you to a smart contract. So this is Solidity. How do we deal with this? What do we do with this? How do we execute it? How do we compile it? What do we do with this? In case you want to know more about Solidity, like there's lots of resources. One that I have prepared here, and you can easily find a Solidity by example. Actually, the code snippet that I showed you is directly from here, where you have some of the concepts explained in simple examples. Like if you're interested, you can look through this. Here's the repo that I have. I will tell you how to get here later, but basically if you just go to this GitHub profile, Martin Tomko Vacuumlabs, that's the only public repository there. And we can jump into the first project, which is the contract itself. And I prepared a very simple contract and I prepared it like in phases. So this is the simplest version. So if you ever wanted to like store a value, but you wanted to do it in a very complicated way, you can use a smart contract for it. You can use this one. This is a very simple smart contract. You have some unsigned integer, which is a part of the state of the contract. I suppose you could think of it like that. And it has 2 functions, get and set, which get returns you the value and sets a new value. That's it. Very simple. Just a side note, you don't really need to have the get function here, because you could do something like this. You could just add public here, and then you would automatically get a getter function called value. Like you could just call value and have the same thing as with get. But for demonstration purposes, we are not doing that. We have these 2 simple functions. Then step 2, something we could add to this. And maybe you don't, when you have a contract like this and you deploy it to the network, anybody can execute its functions, so anybody can set the value to anything else. So maybe you want to protect against that. Maybe you want to set yourself as the owner. So here we add another member variable, which is an address, which you set in the constructor. That's also something that appeared here, a new constructor. And in the set function, you can add this extra line, which what it does is basically it checks this condition. So it checks if whoever is sending this whoever is initiating this computation is the sender, is the same as the owner. And if not, then it will revert, tell you only owner can set value, and it won't happen. Like, it won't let you go further. You will not get to this line in the code. So if you have it set up like this, only whoever you set as the owner, only that address can change the value. And one more thing that I added here is an event. So what you can do is when the value changes, you can emit an event. And this is like some extra way of, like the value will be set. You can always call get and check what the value is, but maybe you want to go through the history of what happened before. And thanks to these events, this will all get stored in the blockchain as well. So this is the contract itself, and that's the solidity part, I guess, but we need to think about like the tool chain around it, like how do we compile this, how do we deploy this. If you want to play around with it and don't want to install anything, there's a fairly simple, easy to use IDE, which is online, called Remix. You can try this. It opens in a browser. It has some contracts prepared there. Like this storage one is very similar to the first one that I showed you. You can compile it, you can deploy it. If you want, just play around with this. Alternatively, you can do what I did here and use some other tool chain. What I chose for this is Truffle. I should say, again, I mentioned that most of what is here is done in JavaScript or the JavaScript ecosystem. To install Truffle, you need Node and NPM or another package manager as a prerequisite. But once you have that, it's fairly simple to use. So I can show you just before I show you the actual, because I have Truffle installed, I can just go to an empty repository and go Truffle init, and it just prepares the project structure, everything I need there. It also gives me suggestions like how do I create a new contract. But I can also already show you the finished product. So here's the contract. Here's the contract. Another thing that you could see that it created was migrations. So these are some. A migration in Truffle is basically what happens when you call Truffle migrate, and usually it's used for deploying your contracts. So here's a very simple script to deploy the contract. And yeah, so I can actually show you how it compiles and how everything is working. And I'm sure nothing will go wrong with this live presentation. So if you do Truffle compile, it's going to compile, surprisingly. And if you want to deploy, it's a bit more complicated in the sense that you have to, first of all, you need to know where you want to deploy. There's a way to have some chain running locally, just for testing purposes. Because we are pressed for time, I will not show you that. I will directly show you how to deploy it somewhere else. So here I have, in this config file, I have prepared the specification of a network called testnet. And the way I set it up is, so if you want to deploy a contract to a chain, you need to send a transaction. And if you want to send a transaction, you have to sign it. So there's pretty much no way to do it without a private key. So the way I set it up here is I have an environmental variable called private key imported here. And here's just some URL of an RPC node that serves that blockchain, which allows me to connect to that. So now if I just do, as I mentioned before, Truffle migrate, if I try just Truffle migrate, it will scream at me because it will attempt to connect to some default network, which is not running, so it will not work. But if I specify the network, it should deploy no problem. It's going to take a while because it has to, as you could see, it first checked if it needs to compile. And OK, now we are done. And this is the very important part of it. Like this is the contract address. This is the address at which this contract is now available. And actually, one thing I skipped and we maybe want to see is the result of the compilation. So Truffle makes these lovely JSON files, which are pretty huge. Like even for this simple contract, this has like almost 3,000 lines. But a lot of this you don't need. But for example, here's the ABI part. This is very useful for you. If you want to write some scripts or whatever that interacts with this contract, you will need this ABI, and you can basically take it from this file. Like, I will show you later how I use it, but if you go through this file, like you will realize you don't need all of this for whatever you are going to do. So, sorry, now, okay, so now we deploy the contract. Just as a side note, like I'm not using any actual Ethereum network. This is a so-called Milkomeda C1 testnet. And I can go to this network's explorer and look for this contract. So it says it's at this address. If I look for it, it exists. There's a transaction that created this contract 2 minutes ago, so that looks like it actually worked. But now what if you want to interact with this contract? Truffle also gives you some extra tools, like there's a console that you can use to send, for example, trigger the functions, the public functions that are available. But instead of that, we can actually use a separate application for it. So here I have prepared a simple web application, which I will first show it to you and then actually, you know what? I just ran it and it is connected to an older deployment of this contract, but because we just deployed it, let me just change so that this one connects to the new one, because it's very easy to change in the source code. Nope, I didn't want to do that. Nice here. Now, let me run this again. Hopefully it has updated. So, now, let me remind you that this is not a talk about web development, so I'm sure you will forgive me that when I try to get, it will only print the result into the console. So as you can see, the initial value is 0, and if I keep getting it, it will still be 0 because nobody is changing it. However, I can connect my wallet, which, like, because I gave my password before, it didn't show up, but here normally it would ask me for a password and whatever. Now I'm connected with some address, with some account, with some wallet. Now I can meaningfully actually try to set the value, because now because this is something also that I didn't mention. The get is also a function, but because it's like read-only, you don't really need to run it on the blockchain. You can just simulate it, and that's actually what happens here. But if you want to set the value, that needs to happen on the blockchain. If you want to have the effects take place there, you need to send a transaction. And for that, you need to connect the wallet. So let me set like 33, for example. I will have to confirm the transaction. And now if I get super fast, there will still be 0. It's already 33, so it's faster than me. So how do you make something like this happen? There are, when you look for libraries, JavaScript libraries to work with EVM-compatible blockchains, you will most often hear about one of these two. either, I'm not actually sure how to pronounce this, ethers.js or web3.js. Now, I pretty much exclusively used web3.js, but for the purposes of this talk, I tried ethers in this project, and the code itself is basically the same in this simple application, but ethers has the great advantage that it's more lightweight. So the original version with Web3 actually needed some extra complicated stuff to configure this project, like some polyfills and stuff you don't want to think about when you are new to JavaScript, just to get it to run. With ethers, it's super simple. Like basically all I did here is create a project from Vite, like just to let you know, like this is what I used to create this whole project. Most of the code that is in that particular project is just created automatically. I can actually show you, not here though. All I did first was npm create Vite at latest, and it asks you a couple of questions, which you answer. Like I chose React, I chose TypeScript, and that's it. And now if you were to compare this to what is actually in the repo, there are not that many changes really. The only additions are this chain file with the code to interact with the contract. Here's the artifact, which is basically the JSON file. I just removed some extra stuff from it and added export default at the start, so it's easier to import. And then I did some simple React stuff to connect it all to the app in this file. But all the other stuff is just automatically generated. I didn't even look at it. For these purposes, you don't need to think about it. So that's an advantage of ethers.js over Web3 in my experience. Like it's much easier to get running. Now so that I actually show you some of the code there. So the idea is you have the artifact. So you compile the contract, for example, using Truffle. You might get different forms of the compiled contract from other tools. I'm not sure, honestly. But Truffle will give you JSON in this form. And if you then use ABI from that thing, like here I directly import the whole object from basically the whole artifact, and I just use the ABI, that's it. It's a great way to basically make the other parts of your DApp understand your contract. You don't have to specify in detail, like I have this function with these inputs. It's already there, you can use it. And let me show you this difference between getting the value. So getting the value is super easy. Both ethers and Web3.js have something basically like this, where you can create some contract object, which will help you interact with the deployed contract. You have to specify the address at which it is deployed. You have to specify the ABI and also a provider, which is basically what enables you to communicate with the blockchain. This is initialized with the same chain URI that I used for the Truffle config. And once you have this, to get the value, you just get the contract, and then there's like functions get. Web3 has slightly different syntax, but it's basically the same. Like I think it's .methods.get or something. Here I'm just directly using the name of the function. And yeah, that's it. Setting the value is a bit more complicated because you have to set a transaction. Like all that this does is it simulates the computation, basically, or I think it asks the node and the node simulates the computation, but it doesn't need to happen on chain. But if you want to set the value, you need to send a transaction. And there's a lot of things you can specify in the transaction. This is a very simplistic version. Like this could actually fail in some circumstances for various reasons. For example, I do nothing to specify the gas price or the gas limit. MetaMask has a bug where sometimes if it doesn't manage to get, actually I'm not sure if it's a bug, but it's really weird behavior. When it doesn't manage to get the gas price from the node, then it tries to set the absolute maximum value, like everything you have in your wallet, it tries to send that. I don't know, but mostly, if you're just trying to start and do something simple, this should work. And so what I do here is I use the contract to prepare like everything that needs to be in the transaction for the purposes of actually calling the code. So there needs to be like a data field there which has some specific binary value which you don't want to do manually. You want to use a function like this to do it for you. And then all the other things I do here is I specify where to send it, which should be the address at which the contract is deployed, and where do I send this from, which is the wallet that I'm using. And this part is still Ethers, but this part here, that's a MetaMask's interface. And basically, it wants to have the transaction object prepared beforehand. So you build a transaction object, you supply it to MetaMask, and MetaMask takes care of everything else. And yeah, if you want to do something like this, you also need to have the login functionality, which also has some similar interaction with MetaMask, like some just calling some RPC methods. I think that's all that's kind of interesting about this particular project. Let me just show you the third one, which is a very simple script. It's, I think, the simplest project of all these. So if I just do, actually, I need to build it first. Actually, wait, this is still also connected to the old deployment, and I want to connect it to the new one. So let me first show you the code because it's very simple. You remember the event that I added to the contract at the very end? What this code does is basically just read those events, and this time using Web3. So here I again built some contract object. Let me actually close this so you can see the line better. On this line, there's a similar construction of the contract object. You again have to specify the address, you have to specify the ABI. In this case, the provider is already there. It's the Web3 thing. And yet, there's just a function to get past events. So from the perspective of the actual usage of Web3, this is basically it. Then there's just some simple JavaScript code to print it out. And if I connect this to our new contract, whose address is here, I need to recompile. And then it's going to show me the history, which is very simple in this case, because I only changed the value once. But if I go back to the browser and do it a bunch more times, then I should get some more interesting results. So let me again connect. Let me set, 42. Now this is going to be very interesting. You're going to watch me press confirm a couple of times. I mean, let's not overdo this. I guess 2 more is enough. If I go back here and try to run the same script again, you can see that the later events are also captured here. And it also shows you the block height at which it happened. Now, if we were to go to the Explorer and look at this contract, you can see that some transactions appeared here. So these are the 3 transactions that I did from the browser. And yeah, that's basically all of the projects. Now, a couple more things that I want to tell you, if I still have time. I think I still have a couple more minutes. So here's the repository on GitHub with all these projects. If you want to use it, at the very last slide, there will be like a QR code you can scan to get to this link. And also, like, we have QR codes on the tables to a different link tree. And this link should also get included there. I promised you before that I will mention some resources. So if you are interested, you can go here. I added some links here. One to a roughly 25-minute YouTube video, which helped me understand the basics of blockchain. There's 2 books, one of which actually David mentioned in the previous talk, Mastering Bitcoin. If you want to do Ethereum smart contracts, you obviously don't need to understand Bitcoin itself, but the first few chapters are a very good introduction to the crypto world in general, I suppose. And then there's Mastering Ethereum, which I found very helpful. And yeah, everything you need to know to get these things to run should be here. Here are some notes how to connect to this one particular network that I used. If you want to use a different one, that's up to you. And also, I should mention, I'm currently working on a blockchain gaming project with Playma Studios. If you are interested in that, you can check out our Twitter or our Discord. And yeah, one final thing that I will show you. So I set up the contract with Truffle, but there are some things here in this repo that are not from Truffle, but from a different toolchain, from Foundry, which is, I suppose you could say, an alternative to Truffle. I believe it can do roughly the same things. One thing that it does, in my experience, better than Truffle is testing, because you can write tests directly in Solidity, which is fantastic, and they are super fast. So I can show you some of those. So just as a refresher, here was the smart contract that we used. Just very simple, get, set. There's the owner, there's the event. Not that much going on. And you can write a test like this. For example, test set, like you set the value and you check that it actually gets set. But what you can do here, you can use like something like cheat codes. For example, this prank function will let you specify like who will be the account that executes the next line. So like if you just try to do it normally, it obviously like won't work. Like you can just send from your wallet. You cannot just use other people's wallets. But here in this testing world, you can just pretend like, okay, this account is the one that will send the next one, and this account is also set to be the owner, so that will work. But here, if you try to set a different account, it will not work. Actually, let me comment this out so you can see that if I, this way, this should fail. So I can run the tests using forge test. And yes, the test failed because I commented out this line. So it doesn't expect the revert. The revert happens, and that's not good. That's an error. But if I, again, put the line back, everything works fine. If you want to see more details about why the test failed, you can increase your verbosity, for example, like this. And then you get a nice explanation like where exactly it happened, why it happened, what's going on. And so yeah, I suppose that's all that I had prepared. So here's the QR code for the repo that I promised, and some contact information for me. And if you have any questions, feel free to reach out to me. I will be here throughout the night. And yeah, thank you.